Greetings, I'm Dev the Developer.
And I'm Glitch.
We've been building a bank account class for a few lessons now. It stores data, protects it, and has methods for depositing and withdrawing. Today, we're going to add two more tools, computed properties and method overloading. Both are simpler than they sound. So our bank account can go negative.
Wait, it can? I thought we had that validator on balance.
We do. The setter rejects negative assignments, but what happens if someone withdraws more than their balance?
Oh, the withdraw method checks for insufficient funds and stops it. So the balance can never actually go negative.
Not with withdrawal, but we could have other paths in the future, and more practically, sometimes you want to know whether an account is overdrawn, even if it's just for display. Say you're building a summary screen. How would you check?
I just check if balance is less than 0.
Every time? In every place that needs it?
I mean, I could add a property like IsOverdrawn, a bool, then I set it to true whenever balance goes negative and false when it comes back up.
Okay. Where would you set it?
In withdraw, I guess, after subtracting.
And if something else changes balance later?
Then I'd have to update it there too.
And if you forget?
Then IsOverdrawn is wrong. It's showing stale data.
Right. You've got two pieces of data that are supposed to mean the same thing, stored separately. What does IsOverdrawn actually depend on?
Just balance. It's literally just whether balance is less than 0.
So, do you need to store it?
Oh no, I can just compute it. Every time someone asks for it, it just checks balance right then.
That's a computed property. Let's write it.
Okay, so how do I write a property that only has a getter?
You write the get block, and you leave out the set entirely. Show the class as it is now. We'll add the balance property.
So something like this.
Exactly. No backing field, no set. Every time something reads IsOverdrawn, that getter runs and checks the balance right now.
That's actually kind of elegant. It's always accurate because it can't be stale. There's nothing to go out of sync.
A value that derives itself from whatever state is currently present. Always accurate, never needs to be told to update.
Never needs to be told to update. Yeah, you'd want that everywhere if you could get it.
You can get it when the data it depends on is already there. Now, you know that fat arrow from methods in earlier lessons? What do you think happens if I tell you it works on properties too?
Wait, so I could write this as an expression-bodied property, like just the fat arrow and then the expression.
Try it.
Let me replace what I just wrote.
Same thing, one line. The fat arrow means when someone reads this, evaluate the right side and return it. No braces, no explicit return.
Okay, so the fat arrow version is just shorthand for a getter that's a single expression. It's the same rule as expression-bodied methods.
Same rule. Once you know it, you just keep finding it in new places.
I want to test it. Let me wire something up.
What did you expect?
False, balance is 50, not less than 0. Yep, now let me try to make it overdrawn. Wait, our withdraw blocks it if there's not enough, so I can't just call withdraw and go negative.
Correct. So how do you test it?
I could just set balance directly to something negative.
Try it.
Still false, I set balance to negative 100.
Look at the balance setter.
Oh, if value is greater than or equal to 0, so it just ignores negative assignments. The balance stayed at 50.
So is overdrawn working correctly? The setter is protecting you.
And so with our current class, IsOverdrawn can never actually be true.
Not the way it's written right now. No, but the property is correct. If we later loosen the setter or add a method that can take the balance below 0, IsOverdrawn will catch it without any changes. It's just watching balance.
Got it? The logic is right. The class just hasn't given it a chance to trigger yet.
All right. flip back to the class. I want to look at deposit and withdraw.
Okay, I'm looking at them.
Those don't have the word static on them. Every method you wrote back in early lessons did. Do you know what that means?
Static means you can call it with just the class name, right? Like console.writeLine.
Right, a static method belongs to the class itself. No object required. What's the opposite of that?
An instance method, it belongs to a specific object.
Exactly. When you call account.deposit, you're not calling a method on bank account, the class, you're calling it on account, that specific account. And inside the method body, balance and owner refer to that account's data.
So the method runs in the context of the object. That's why we don't need to pass the balance in as a parameter. It's already there.
Right. The absence of static is a signal. No keyword needed. The method just lives on the instance.
Okay, that's actually a cleaner mental model than I expected. Static is the special case. Instance is the default.
That's a reasonable way to think about it for a class like this. Yeah.
So every method we write on a class is an instance method unless we say static.
Unless you say static, yes. Now, glitch, I want a deposit that also logs a memo, a description of what the deposit is for.
Oh, that's easy. I'll add a new method. I'll call it deposit with memo, takes an amount and a string for the description.
You don't need a new name.
What do you mean? There's already a deposit method. I can't just write another one with the same name.
Try it.
That's going to be a compiler error, but fine. Oh, it just accepted that. Two methods named deposit.
Why do you think that worked?
Because the parameter lists are different, the first deposit takes 1 decimal. This one takes a decimal and a string.
The compiler can tell them apart. When you write account.deposit with 1 argument, it picks the first one. 2 arguments, it picks the second. That's method overloading.
Okay, so the rule is same name, different parameter list, and C# figures out which one you meant based on what you pass in.
Parameter count, parameter types, or both. Any combination that makes the signatures distinguishable.
Wait, so what if 2 overloads have the same types but in different order? Like one takes a decimal, then a string, and another takes a string, then a decimal.
That works. The compiler looks at the position and type together. It can tell deposit 100 rent from a hypothetical deposit rent 100.
What if the return types are different but the parameters are identical?
That does not work. Return type alone is not enough to distinguish overloads. The compiler looks at what you're passing in, not what you're doing with the result.
That makes sense. The call site doesn't always make the return type obvious. Like you might just call a method and not assign it to anything.
Exactly. The rule is the call site has to be unambiguous from the arguments alone.
Let me test the overloads.
What do you expect?
First call uses the original deposit. Second uses the new one and prints the memo. Balance should be 50 from before plus 200 plus 75, so 325. There it is, both deposits running. C# just pick the right one each time.
It always picks the right one. That's the contract. Same name, different signatures. The compiler dispatches to the correct version. The caller just describes what they want to pass in.
So you could have a whole family of related methods that all share a name. Each one handles a slightly different input situation.
And the caller doesn't have to know or care which overload they're hitting. They just need to describe what they have.
That's actually a pretty powerful form of control. The same entry point, routing to totally different implementations, based entirely on what gets passed in. The caller never chooses, the system decides.
The compiler decides at compile time before anything runs.
Right at compile time, sure, that's what I said.
Anyway, let's look at the final class. IsOverdrawn, 1 line, no field, no setter, no sync problem. Just a question that answers itself by looking at what's already there. And 2 deposits that share the same name because they share a purpose. The class tells you what they do, The arguments tell C# which one you need. Those seem like two separate things, a computed property and method overloading, but the lesson underneath both of them is the same. You don't always need more names and more storage. Sometimes the data you already have is enough and the language is smart enough to work with that. You just have to let it. Now, take that bank account, build it yourself, and extend it. Don't just watch it. Do it.